when we were at Frankfurt Airport, we had a pass where something had to be done. So my colleague with a laptop in the waiting room of Frankfurt Airport was controlling the spacecraft very securely. So here you see our control center. Here is all the equipment, the control screens, etc. So BRITE Austria is operated from Graz, UniBRITE from Toronto. However, and this is now something which is very appropriate for this meeting here, since October 2013, so this was about 6 months after we started, we experienced very strong interference on the UHF uplink. So the blue line is what would be the nominal power at our spacecraft, and here you see the interference is sometimes 30 dB stronger than the nominal signal. And we are pretty strong, so we can feed a kilowatt in an 18 dBi antenna. So this is roughly 48 dBW, so it's a lot of power, and still the interference is much heavier. But you also can see it is pulsed. So we measured with several satellites over Europe, and it's all consistent. This is another picture. This was taken with 2 spacecraft. Green is ours, red is the Polish spacecraft. Again, you see the pulses, and there you see something interesting. Normally, interference continued up to the end of the pass, nearly to the end. The last 2 minutes are always without interference. But here it stops and it ramps up on the Polish spacecraft, which was on a different location. So basically, the signal is very strong, the signal is pulsed, and it's highly directional. So I leave it up to the audience to guess what the source might be. Here is another measurement. So these are successive passes which can be observed from our ground station. And here you see the red ones where we measured interference. It's not very nice. Also, it impaired the commissioning of the Polish spacecraft from Warsaw. And there are a few other cases where others have consistently the interference on the UHF band. However, this is amateur radio band. It's secondary assignment, so there is no protection. Just a few words how we operate. So there's an executive science team which decides on the targets to be selected, and then it's up to the operations teams to send the commands and do all the data collection. I'm very happy to say the spacecraft is operating very well. The specification was that we have a pointing accuracy, so for 2 to 3 pixels of pointing accuracy when we take an image. We are now at 1.6. And this means, because we have to put a star into a raster of nominally 32 times 32 pixels, and now we could go to 24 times 24 because pointing accuracy is so good. Also, temperature on board of the spacecraft is very nice. On average, we have about 20 degrees centigrade, so everything is very healthy on board. And here are just 2 pictures from the scientific observations. The blue dots are images being taken during one orbit, averaged, and these are successive orbits. So the red curve is just due to the pulsations of the star. Now, somebody may say, how would I know that this is not a temperature effect you have measured here? This is the counterproof. This curve, the gray one is with BRITE Austria, the blue one with UniBRITE, looking at the same stars, and it's all consistent in the variation. So, some legal matters here have mentioned it already. It has been properly frequency coordinated. Also, BRITE triggered the implementation of the Austrian space law, which is in force since December 2011. I mean, our minister is very positive on small satellites. She told me once the Austrian space law was the only one she ever passed through parliament without any discussion from the opposition. So also we gave a one-to-one model of our BRITE as a present, and it's in her office. So another good point for giving a good flavor to small satellites. And our notification process was such, so we delivered all the data to the Ministry of Transport, Innovation and Technology, and then the Foreign Ministry did the official registration with the data bank at UN OSA. So in conclusion, BRITE constellation is the world's first nanosatellite mission dedicated to an astronomical mission, quite a challenging one, and it demonstrates that you can do serious science with a challenging, demanding scientific mission with a small and fairly inexpensive spacecraft. So the BRITE satellites, the Austrian BRITEs, have traveled 10,000 times since launch around the Earth, traveling approximately 450 million kilometers. We have been observing the star fields Orion, Centaurus, Perseus, and Vela Puppis, each one about 100 days so that we can average properly. The observing period is already defined up to the end of 2016. And when we look at the performance of the spacecraft, we can happily operate, if nothing serious happens, for another 2 years. The limiting will be the degradation of the CCD. Scientific data analysis is well underway. In September, there will be in Poland a scientific congress where all the data will be presented. In our case, the spacecraft had been entirely funded by the Austrian Aeronautics and Space Agency. And here you see all the logos of the participating entities in BRITE. And with this, I thank you very much for your attention.
Super, super, Otto. Thank you very much. Excellent. If you accept questions during lunchtime, because we will run after really the serious difficulties. Next project is little bit shy project from Hungary. Where is the presentation? If you can find it, Tuesday morning. Which one? Hungary. ITU, this one. This one. Yes, there is Levente DUDAS who will make his introduction, but before, like I have for all CubeSats a short story, I have also with them a big story, and because we have to little bit understand also what is behind. When I learned from one of my colleagues in ITU, he came to me once with a coffee to say, look, we are going to have a first CubeSat from Hungary. You know, I am from Slovakia, how I was. And I told him, oh, okay, but where is the filing? He told me, I don't care. I told him, okay, you don't care, but you know, we are idiomators, we have friends everywhere. That's why I picked up the phone and I told, hey, Bandi Baci, there is one gentleman, Dr. Professor András Schwind, who is like Otto and Jordi. Behind there is always a strong professor. He's what, 70 years old? A little bit more? Yeah. Very nice person. I know him 50 years. When I was a small starting radiometer student, I looked to him because I live in the border close to Hungary, that's why. And Bandi Baci was very nice with me and he told me, what's you talking about me? He was close to put the phone. We are on the amateur bands, go away. I thought, okay, what can I do with him, big professor? Okay, I thought, okay, goodbye. 5 minutes later, I picked up the phone in the Hungarian telecommunication office. I thought, look, you are going to have a small satellite first in Hungary. And they thought, what? I thought, yes. We never heard about it. You hear from me, go to the technical university, speak with them, and by the way, we are ready to help. In 3 days, the filing came, and we have a successful MASAT. That's why, Levente, let's go.
Thank you. My name is Levente DUDAS from Budapest University of Technology, from Department of Broadband Info Communication and Electromagnetic Theory. And I'm responsible for the communication subsystem of MASAT-1 and, of course, the ground stations of MASAT-1. So this development started in 2007, and this kind of CubeSat has a 10 centimeters cube. Its mass is less than 1 kilo, 998.5 grams. And it consists of several subsystems. For example, electrical power system 1, 2, and 3. This is the half of the satellite. And of course, onboard communication, onboard computer, of course, electromagnetic stabilization system, and of course, the communication subsystem of the satellite. And these subsystems are called redundant subsystems. So from the main subsystems of MASAT 1 contains 2 ones. And if any disturbances, if any failure in case of the first one, for example, OBC, the task is to switch to the another part. And this PCB is the communication subsystem of the satellite. Here is the COM, the first and the second. And during the frequency coordination with ITU and ERU and the local authority in Hungary, and of course the United Nations. For example, we will have small satellite, and because of the exportation of the satellite, you can contact with United Nations, of course. And we received the call sign called HA5 MASAT. And of course, the ground station is the Budapest University of Technology primary ground station, and own call sign is here. So this kind of communication system works on the UHF band, 2 different transmitters here and here, 2 different receivers on the UHF band with a redundant part, and 1 VHF receiver to the switch off command, to receive the switch off command if MASAT 1 causes any disturbances to other satellite communication system. And this communication system is based on single chip transceivers from Silicon Labs. And this is before the launch, the CubeSat, and the radiation pattern of the monopole omnidirectional antenna is here, is shown here. And a very long journey was in 2011 from Budapest across Nordwijk to Toulouse and Kourou, and with in a cooperation with the European Space Agency, with the Vega maiden flight in 2012, we launched with this rocket. And after the start of the list of about 71 minutes after the launch, we have put it to the orbit. And after that, you can see the opposite part of the communication system, the ground station. We have a fully automated and remote controlled ground station at the Budapest University of Technology, like a primary ground station. We have 4 18 elements cross-reagies on the UHF band, 2 different 14 elements cross-reagies to the VHF band, and all equipments, including this outdoor racks on the roof of building E. And of course, because of the cold redundant subsystems on board the satellite, we have a secondary ground station, and we have 3 meters diameter dish on board on the building E, which is able to measure the rotation of the polarization of the MASAT 1 during the deorbitation, which this kind of primary radiator contains 2 independent receivers with 2 perpendicular polarization in front of the dish. And of course, we have a secondary ground station is at home, which can control the MASAT 1. And we reached almost worldwide radio coverage to be able to receive the MASAT-1. So more than 200 radiometers all around the world to have received MASAT-1